Thanks for coming along this evening. I appreciate it's a lovely evening and a lot of us would rather be down the pub, I'm guessing, but gave me a chance to ride the bike over, so I'm a happy man. We're going to be talking about Azure SQL Database, managed instances. Before we go into the slide deck and stuff, has anyone, apart from Richard and Sylvia at the front here, heard of managed instances or seen anything about them? A couple of people. Who here's using Azure SQL Database at the moment? Right, it's basically the same thing. Right, presentation done, let's go. No. We'll cover what they are and how they differ, but they're built on the same technology, so we'll have a look at that one there. A little bit about me. My name is John Martin. I'm a product manager for a company called SentryOne. We're an ISV, we build monitoring software and stuff like that. And I'll give a license to give away tonight if the swagometer's working and stuff. Only this time I hope I don't win the license, like I did last time I gave one away. Microsoft Data Platform MVP, working with Data Platform in one form or another for well over a decade now. Started off writing DTS and reporting services reports back in SQL 2000. Done time as a SQL dev, BI developer. I'm now a reformed DBA. Prior to joining Sentry, I used to work for Microsoft as a premier field engineer based out of the UK. I'm also director at large for EMEA for an organization called PASS, which is a Professional Association of SQL Server. It's basically an organization that puts on conferences, helps run events and things like that about data platform technologies, be it relational, non-relational, Azure, AWS, whatever. Keep an eye out for stuff. Contact details are down the bottom here, so please feel free to tweet at me, email me, read stuff I blog about. I've also blog at a website called MS SQL Tips. One of the demos we're going to do towards the end, all of the code is up there in my blog post which went live today. Convenient. So that's cool. Yep, don't need that. I'm just retasking a deck from work. So, what is Managed Instance? It's a new platform as a service offering. That's obvious. As I said, it's built on top of Azure SQL Database. Or rather, not built on top of, it's another flavor thereof. Okay. We've got Azure SQL Database, the singletons. So you spin up a Azure SQL Server, then an Azure SQL Database. You've got Azure SQL Database Elastic Pools, which is essentially allows you to group a bunch of them together and get better utilization across the field when you're using Azure SQL Databases. So you're paying for less throughput, and then you're basically looking at seasonality in your workloads through the course of a day. That's how we leverage Elastic Pools. Now Microsoft have added Managed Instance. The reason they've done this is because there are a large number of blockers for migrating an existing on-premises workload, existing application databases, things like that to Azure SQL Database, quite simply. There are a number of restrictions around the functionality of the platform, such as, now I'm going to say you can't do cross-database queries. You can't do three-part name queries in the traditional sense of the manner. So you can't say, select star from database.schema.table. Can't do that in Azure SQL Database. Okay? There is something called Elastic Query, which allows you to create what are referred to as external tables. Essentially, you create database scope credentials and you log into the other databases. You've got no sense of the instance like we do with your retail SQL Server environments. That's where this comes in. It fills an awful lot of those gaps in capability. Okay, making it a lot easier if you want to get, if you've got old servers, you've got old versions of SQL that are being retired by Microsoft, then it's simply a case of, okay, maybe we can do this and stick our apps in a VM, deploy it to app service, things like that, okay? But the important thing to understand here is, it is Azure SQL Database, okay? What that means is, you're running on essentially vNext all the time. It's got the latest bits. There's no updates, no infrastructure, that type of thing, okay? Which brings us on to the question I've been asked a lot, is it really PaaS because you're saying an instance? Yes. Because when you look at it and you run select at version, it's Azure SQL Database. Now this is a fun one. The version numbers between SQL Database and retail SQL Server, two different things. They diverged a long time ago, okay? So when you run select at version and tells you a V12 database, it's not talking SQL Server 2014, okay? About 4 or 5 years ago, Microsoft retired the original form of Azure SQL Database and replaced it with what they refer to as a V12 database type, okay? So yeah, there's been a lot of discussion online and in various groups I'm members of, but it says 12, that means 14. No, okay? You go to Azure SQL Database, you run exactly the same command, you'll see exactly the same version numbers. You may see slightly higher on Managed Instance at the moment because it's still running through public preview, but it is Azure SQL Database under the hood, okay? So yeah, don't worry if you do that and you see 12. It is the latest bits. It has got all of the latest capabilities that SQL Server 2016, 2017 has from an engine perspective, plus a whole bunch more when it comes to the programmability and the surface area, okay? But yeah, it is PAS. Essentially, what that means is no OS to manage, okay? Now, Microsoft are expanding the OS footprint for SQL Server Retail to Linux, which allows us to use it in things like Docker containers and what have you. But it still runs on Windows, but operating systems still need to be maintained. No SQL Server patching. Microsoft have gone away from service packs, quite simply. They're now running on a much more frequent cadence of pretty much every 60-ish days, they're dropping a cumulative update now. The reason that Microsoft are doing that is because they're running Azure SQL Database and they're starting to feel the pain that we felt for a very long time. So it's in their best interest to actually fix this now. So the retail side of things is reaping the benefits of it, but it does come with a big administrative overhead. That's not there because you get that continuous deployment capability that Microsoft are running with the Azure platform. When they bundle all the fixes up, out they go. High availability disaster recovery built in. Built in. This is a fun one. Under the hood, because it's Azure SQL Database, you've got multiple replicas of the data, okay? Multiple databases. It sits on top of, and we'll cover the storage later, but essentially it sits on top of Azure storage, which again is replicated storage. They run a huge amount of consistency checking and everything under the hood. So again, that tends to alleviate things like the need to run CheckDB, which is database consistency checking, identifying corruption. Microsoft are doing a lot of this in the background, okay? The high availability, yeah. I can only talk about the general purpose variant at the moment because that's the one that's in public preview. There is another variant called Business Critical, but that's all I can say at the moment because they made me sign some paperwork. But essentially it's built on top of the Azure storage and it's multiple replicas and it just, the high availability. If the compute fails, it brings another bit online. If the storage fails, it just swaps it out in the background. Okay, so there's a lot going on there that we don't need to worry about anymore. Building highly available data platform solutions, it's the joys of platform as a service, okay? Disaster recovery, they do the backups for you as per Azure SQL Database, and you've also got the ability to then leverage long-term retention for up to 10 years if you configure it. Small tangent, if you do, and this goes for Azure SQL Database as well, if you set up long-term retention, delete the backups in long-term retention storage before you delete the database. Because if you do it, you essentially orphan the storage and it's a real pain in the backside to go and find. You end up still paying for it because it's still there. Delete the storage, delete the backups first, then delete the database. Otherwise, it costs you money. So now we start thinking about, okay, well, where are Microsoft taking this? Is it the equivalent of RDS? Well, kind of. Okay, RDS is a halfway house between Managed Instance and Azure SQL Database from a functionality perspective. Okay. The big differences here are that Amazon are running theirs on the retail variant of SQL Server. It's all they've got available to them. They're running up VMs in the background, and underneath there, they're essentially abstracting that off. Okay, so you have got the ability to, from a compatibility perspective, you've got the options there of going 14, 16, 17, and deploying that under RDS. So it depends on the applications you're going to be running as to whether or not you can leverage that. Whereas Azure SQL Database, we're going to be running on the very latest builds. It's continually updated in the background. You do have compatibility mode. Compatibility mode is all about how the engine will handle, interpret, and execute your T-SQL, okay? Depending on which compatibility mode you have in place at any given point in time, you may see different behaviors. Most notable are some of the DMVs. So a good example is back in the 2008 compatibility modes. If you nest things like the DBID function into the index physical stats management function, it won't work because that doesn't, for some bizarre reason, the database ID function just doesn't work when you nest it. Bring it up to 2012 compatibility mode, works a treat. Okay, that's what compatibility mode is. If you do deal with retail SQL Server on-premises, VMs, things like that, it doesn't mean that you're running in a database at a lower level and can take it back. It's all about how the engine interprets the T-SQL. From an authentication perspective, both of them have SQL Server authentication capabilities. Okay, both of them have directory integration. RDS uses Amazon's Active Directory integration mechanisms, which in my experience is not the easiest thing to set up. If you start looking at building hybrid environments, so if you're working with an on-premises estate at this point in time, where you've got an enterprise Active Directory and things like that, and you want to facilitate single sign-on through the applications, it can be a bit of a pain in the butt to set up. Conversely, Azure Active Directory, really easy to set up, but unless you've engineered your applications to leverage it, it goes down the pan. You can't fire up, say, a Windows service. So, for example, if you take a standard off-the-shelf ISV app such as our one, we're running as a Windows service, we haven't yet architected in the ability to authenticate against Azure Active Directory. So if you're running it as a Windows service with a Windows user on a virtual machine that's connected to your traditional Active Directory, if we try to authenticate against Azure Active Directory via managed instance, it will fail because the protocols and the APIs are different. Okay, Microsoft have released preview, I think the term is now, .NET 4.7.2. I don't think it's gone GA yet, but that has a number of, well, for a start, it's got a number of fixes in and around the Microsoft Data Platform components that it's built into, but also they've enhanced the capabilities when it comes to making it a lot easier to build applications that will authenticate against Azure Active Directory. So if you are looking at doing that for sort of single sign-on, running of services and things like that against Azure Active Directory, have a look at .NET 4.7.2. One of the big things with RDS is that you don't get full SA privileges, okay? Also, whilst you have got things like SQL Agent, you're limited, so if you create jobs, you're the only one who sees them, okay? So if you want to run your index rebuilds and stuff like that, you set it up and off you go, but no one else finds it easy to have a look at it. Essentially, the MSDB database is locked down. With managed instance, it's full SA rights, okay? You've got sysadmin privileges. You can do as you need. Is anyone here using RDS at the moment? Ooh, oh. Of the two, I can see benefits in both, depending on the type of applications you're building. If you still need a relational engine and you want a very fast path to building something, managed instance makes life a whole lot easier. So that's what we have. Now, what are the workloads? Essentially, Microsoft are really saying, if it runs on retail SQL Server, there's a greater than 90% possibility that we can run it on managed instance, which takes away all the server costs, it takes away the operating system costs, the management overhead of having to stack rack servers, put it all in, that type of thing, okay? There are going to be areas that it doesn't work as well. Because it's platform as a service, if anyone's using functionality like replication, for example, at the moment that's not scoped in to be full parity yet, because it's running on the Azure Service Fabric. All of the, under the hood, and we'll have a quick look in the DMVs later, but under the hood there's a whole pile of applications running on Service Fabric essentially that go into making this service up. The log readers and such like are not there for replication. It can be a subscriber for push transactional replication subscriptions, but it can't do pull subscriptions. You can't set it up as the distributor and you can't set it up as the publisher. ISV third-party applications, custom apps, things like that. If you're running it in the engine, if you're using column store, if you're using Hackathon, all of those features are there. We recently architected our platform, made some changes to it. Now we can monitor it, now we can actually run our database on it. Relatively simple modifications to make, okay? I think it took us 1.5 sprints to get all of the work done, and our sprints are 2 weeks long. So we did that, got everything, pushed the release. Everything was good. I was happy anyway. Cloud migration, hybrid deployments, they're really gunning for the enterprise with this one. If you're building cloud-born applications from the outset, if you're going to use relational Azure SQL Database, Singleton or elastic pools is probably the best way to go, so long as you're familiar with that. If you're not familiar with that particular one yet, you can look at doing this. There is no direct migration path, so you can't take the database and just say actually move it to an Azure SQL database, even though it's the same platform under the hood. You've got to essentially do the whole generate a backpack or spit the schema out or use any of the migration services to take it from one service to the other. Okay. There are a lot of requests for them to add that capability of a push button, move it. So fingers crossed, that'll come across. So coming back to your question earlier about agent jobs, agent is there. Full-blown SQL agent, including database mail. If you've got an external SMTP server such as Office 365, Google, things like that, you set the DB mail up. We have the same functionality that we have on-prem. But yeah, full SQL Server agent. There are certain restrictions around the job types. You haven't got command exec because there's no command line there anymore because you're not running on a traditional operating system. But a lot of the other ones there, the integration services and stuff like that, because it will work with some of the other platforms of service offerings in and around ADF, integration services in the cloud, which is courtesy of Azure Data Factory and things like that. You can put the integration services catalog on managed instance and stuff like that. CDC, change tracking, we've got access to those now. Never had them before. The big one here, cross-database queries, native three-part names. Because you're in the context of an instance, it knows that there's multiple databases in this collection. So yeah, so long as you've got the traditional login and user configurations to allow you to see and interact with those databases, yeah, you can build queries that do cross-database queries. So joining data from databases 1 into 2 and 3. It's not a design pattern I like because it's a real nightmare to manage and migrate databases if you ever have to scale things out. But there's an awful lot of it out there. Best one I ever had to deal with was working for a company where we had, it was an access front end for SQL Server back end. It's about 100 and something databases, one database which had about 50 tables and then 100 and something views into all of these other databases. Doing three-part naming, that's bad because when I had to move that, it took me 6 months to move a database because I had to re-architect a whole pile of it. Linked servers are in. Okay. Linked servers just means that we can access things. At the moment, that's restricted to other managed instances and other SQL servers. Retail SQL servers running in VMs, on-prem, if you've got the networking in place, which will jump over Service Broker, which is essentially Service Broker within the instance. Inter-instance Service Broker doesn't function yet. They've got it slated at some point to deliver. The big one here, though, is VNet deployment. It's one of the biggest issues for enterprises that they had, and also many, many other people when they were building applications in Azure, was the endpoint is always a publicly addressable endpoint. It has to be unique. Okay. What that means is, when you go to set the permissions up, you can say, I want to restrict it so that only these IP addresses are able to come in, or other Azure services, and there's a tick box for that one. That other Azure services tick box basically means any Azure service, whether it's in your subscription or not. So if someone got the credentials, the login, so the server name, the database name, username, password, from other subscriptions, they got full access to it. Okay. Be very careful with that one. Now, what Microsoft did was with managed instances, the managed instance entity that you create in the Azure portal and the Azure platform is deployed onto a VNet. So this is a virtual network subnet segment. Okay, there is no public IP address, public endpoint. So that locks that down. But what that does mean is your applications have got to be able to connect and traverse to that VNet. Now, there are various different service endpoint options available. So if you're running Blob Store Azure SQL Database, you can put them onto VNets now through the service endpoints. Additionally, with App Service, there is a container solution essentially that will allow you to basically come in through the networking portion there. So if you are deploying directly to App Service in the Platform as a Service offering, you can get that networking into the VNet and not have to traverse the public internet. If for whatever reason you do want a publicly available endpoint, you're going to have to look at third-party solutions in the Azure marketplace. Essentially looking at Kemp, F5, Barracuda. They've all got virtual appliances that will be firewalls, web application firewalls, load balancers, all of that sort of stuff. And they're a lot more secure than just trying to sort of hack it open with something like RAS server on Windows and stuff like that, where you've got public endpoints and stuff like that. Set up the device, then it'll give you full access control, allow you to do TLS and all that sort of connection level authentication, connection level encryption. It'll make life a lot easier. We also have the ability to take native backups. So we can run a backup database command, but it's copy only. And we can push it out to blob store. The reason for that is because if you want to migrate them between managed instances, you've got to take a backup and restore it from blob store. File layout as well. Now with Azure SQL Database, that's it. You deploy the database, everything is managed for you. Storage, tier, the works. Okay. Here we've actually got the ability to manage file groups and files, so you can spread your data out. You can basically partition it as you need. You can say, actually, I'm going to put all of this data for 2016 into this file group and these files and what have you. Okay, so you've got that versatility. That becomes very, very important because when we come on to here, next, no, thank you. No public endpoint, which you said, but it leverages Azure storage, okay, premium storage. What this means is that under the hood, you've essentially got somewhere in the region of 200 Azure premium disks. Now, they are P10 through 70. If you look, I think I've got it in the slide deck as a link, which I'll put up online. But essentially, the size of the file, or rather the size of the disk, will dictate how much I/O you get through the Azure platform. Okay? So the larger the disk, the more throughput you get, both in IOPS and megabytes per second. Basically, Microsoft are making an assumption that the bigger the database, the more you're going to interact with it, or the bigger the storage. So what this means is, because you've got access to the database files with managed instance, you can just basically bloat them up with empty space. Okay? Make them big, which means if you bump them up to, say, terabyte-size files, what that means is you'll then get the P70 disk, which has got all of the throughput. Even though you've got a very small amount of data in those data files, you've got the full capability of the Azure storage platform available to you. Storage is pretty cheap, okay, as far as Azure's concerned. When you think if you want to bump it up, if you've got one database at the moment, it's 120 gig, you just turn it into a terabyte-sized file, you'll be paying maybe a couple of pounds more a month. Okay, but the capability and throughput you get is worth way more than that. Okay. Business critical instances, this is about all I can say about them at the moment, but they use local storage on SSD. Okay, local to the compute. Another benefit, coming back to the no public endpoint piece and the fact that we're deploying onto VNets, means that you've got a lot more control. If you are working from an office environment and things like that, you can establish a SitetoSite VPN, which means the traffic between you and Azure is encrypted. Whereas previously with Azure SQL Database, Singleton, Elastic Pools, you're going over the public endpoint. Yes, it'll be doing TLS encryption on the connection between your app and what's up there, but this just gives you that added protection. You know where it's going. Okay, you know the route that it's taking. Likewise, if you've got very deep pockets, you can buy ExpressRoute, which is the high-speed, low latency, high bandwidth MPLS capabilities that essentially you peer into the Azure network fabrics. So over here it's BT, I think, that provide that capability. Essentially you say, here's a huge wedge of money, give me a very big pipe to Azure. If you've got vast quantities of data to do, have a look at it. Now, one of the fun things is we think about migrating database, and we'll talk about in the back half of the presentation. If you don't have to go down the route of Azure ExpressRoute, or you don't have to go for VPN and wait for weeks. You can put stuff onto USB disks and ship it to Microsoft. Essentially, you BitLocker the drives, you put all the stuff you want on them, you ship them to the data center, and then they put it into an Azure Blob Store account for you. So there are ways around it if you don't want to spend lots of money on networking. Any questions so far? Okay. Let's try a quick demo. So what we have here is managed instances. So we think about the Azure portal. Anyone here use Azure at all for anything? Awesome. Essentially what we now have is managed instances as an option here that we can use for creating as a service. Okay. So nice and happy when we create them. At the moment, this is what we see. Managed instance. Still the standard behavior for Azure. You've got to build the resource group, you put it in the resource group, and most of the other stuff is managed for you. So we've got West Europe is where I'm storing it, and which subscription it's in. So let's jump in and have a quick look at it from the portal here. So what we're able to see, various different options available to us, pricing tier. Now, like Azure SQL, no, this is a fun one. Microsoft changed the way that Azure SQL Database is scaled and built, okay? Up until about 2 weeks ago, you only had the option to run what they refer to as DTU, Database Throughput Unit, which is a magical number that they calculate based around how much I/O, so log I/O, data I/O, and CPU you're using, okay? Managed instance, when that was introduced into public preview, essentially, gives us the ability to say how many virtual cores we want and how much storage we want, okay? So it's more akin to, we know that we're running SQL Server on a machine that's got 4 cores and that much storage. That's how they're trying to ease that burden of migration and scaling it and picking the right sort of size. Because with DTUs, it's like, well, do I need a basic, a standard, or a premium? And then within each of those, how big do I go? And the top end P databases, you're talking upwards of $10,000 a month. So it's important now. So managed instance brought in vCores. They've actually brought that now down into Azure SQL Database itself as well. So you've got both you've got the DTUs and vCores as an option when it comes to creating Azure SQL databases. My suspicion is that DTUs is going to go the way of the dodo. And we're going to be sticking with vCores, so just be aware of that one. But we have got the ability to scale up and down as needed, okay? At the moment, we've got limited capabilities here because we're still in preview, but one of the key ones here that's worth thinking about is the joys of platform as a service means that Microsoft's got a lot of capabilities built in, okay? Threat detection being one of them. It's a key part of the Azure platform. Because they're looking at all of the network traffic across the entire Azure estate, they're able to run machine learning, heuristics, and things like that in the background to look at help identifying potential threats to your systems. And it's as simple as ticking 3 boxes and saying, yes, turn this on for me. Okay? So it can do that detection. Is someone trying to brute force your account? Are you liable and susceptible to SQL injection? Is someone trying to do SQL injection attack against you? All of this is capability that exists for Azure SQL Database in platform as a service, and at the tick of a box will be able to sort of be available for you to understand and get advice from the platform. Okay. Other than that, we can see managed instance databases here. I've only got one of them at the moment. That will change later. How much CPU I'm using, how big it is. You'll notice here, this is the pricing tier, which is the configuration I'm using. Now, the size that you've got is 8, 16, and 24 vCores, okay? Now, depending on which generation hardware you end up on, depends on how much memory you're going to get. Now, at the moment, Microsoft has stated that it's anywhere between 5 and 8 gigs of RAM per vCore, okay? So as you scale the system up, you're going to get an increase in memory as well. And if you're on the Gen 5 hardware, in all likelihood, you're going to get a bit more memory. Okay. At the moment, I think I'm running on a G4. I think. I've got a couple of them in subscriptions and they're on different bits. So yeah, we've got a various different pieces to have a look at here. Threat detection, connection string settings. There's not much here from the portal. Okay. We can also say how much storage we want, up to 8 terabytes at the moment. I'm sure that will get larger. One of the big things that is useful though is if you've got existing on-premises licenses under SA, you can tick this little box down here and it will save you money. Essentially, you get license transportability. So if you paid for software assurance licenses on-prem and you decommission those servers, you can basically transfer the licensing and offset your costs. So Microsoft offer that with virtual machines and with a couple of other options as well. So if we bring up this one a second and then we'll break for pizza in a moment. So I think Zoom is running here. Yes, it is. So I've added to Object Explorer here, managed instance, a local retail SQL Server instance, and Azure SQL Database. Okay. Now we'll concentrate on these two because essentially they are fundamentally the same thing. Zoom in. There we go. So here's my managed instance. You can see I've got databases node. Here's my retail SQL Server. I've got that as well. Okay. And I can drill down. I've got all of the databases there. Security. I've got logins. See server objects. So endpoints, linked servers, all of that sort of stuff. The system databases are all there. You remember what I said earlier about it being version 12 databases? 12.0.2000.8. Okay, that's not 2014, that's a V12 Azure SQL Database. If we come down, you'll see that the Azure SQL Database I'm connected to is also that particular version. But how does this differ? When I log into it, all I get are some databases and some security settings. Now, the reason I see all of the database here is because I've connected with a server level account for Azure SQL Database and connected to master, so I've got visibility all of those. If you've got connectivity into a single database on Azure SQL Database, you see that in master. You'll also notice here that I've got an Azure SQL Database data warehouse on that particular one. That's not functionality that comes with a managed instance. That's discrete. Okay. So whilst you can coexist SQL Database and SQL DW on the same logical server entity, you can't do that and have a DW in managed instance environment. Again, from a security, you've got logins there. You'll notice up here, we've got things like credentials, server roles, and things like that. They just don't exist for Azure SQL Database, but they do up here for managed instance. Credentials in Azure SQL Database are at the database level, not at the logical server entity level. We've got credentials here in managed instance because that's how we interact with blob storage, and that's what we're going to look at in the back half of it when we go through a migration phase. It's got built-in high availability around data synchronization, resiliency, all built through the platform. Now, the big issue comes when we start thinking about things outside of the database and outside of the database server. Logins is a real classic one, okay? Network shares, well, we can't get to them because we're platform as a service, okay? Likewise, agent jobs, if you're dealing with things like, for example, I'm using XP Command Shell for some bizarre reason to move things around. Not going to happen. We need to re-architect those, okay? We have got CLR back, which we lost for a while in Azure SQL Database because of the way that it needs to be sandboxed and isolated and things like that. Managed Instance is bringing that capability back. A guy called Jovan Popovic has got some really good stuff up on GitHub. He's also got some what I would consider truly terrible things on GitHub, like building a CLR routine that uses curl to call a web service directly from the database. Please don't do that. It's the quickest way to kill performance in a database engine. But yeah, Windows logins, networks, file stream. Now this is a fun one. File stream will not work on the general purpose platform. The reason being is that you need local storage essentially because you're essentially dealing with network attached storage. Doesn't work. So if you're using file table, file stream, also Hackathon, the in-memory engine, relies on file stream-like capabilities, okay? Now when we start thinking about these compatibility checks, I mentioned there's some scripts, so you can do it all yourself if you fancy reading the documentation and hoping that it's up to date. The Data Migration Assistant, it's both a blessing and a curse, okay? It was developed by a different team And it's a command line app. It's not integrated with PowerShell. The fun one is, if you want to deal with multiple databases with it, you need to feed it a connection string, a full connection string for every database, which means it gets very verbose very quickly when you're dealing with a large amount of data, databases, sorry. Okay? But it is very useful. One caveat, be aware, if you're using XML queries in your database, in views and stored procedures and things like that, it can flag those as cross-database queries when they're not. I've spoken to one of the PMs about it and told him. I said, please fix this. You know, if it doesn't work with AdventureWorks, I don't know if anyone's familiar with it, is Microsoft's old sample database system. It was fantastic because it had so many things wrong with it, it actually looked representative of what a real-world database was. So yeah, it's like if it doesn't work with that, then chances are that in the real world, people are going to be hitting this, okay? And then you need to think about the migration process. Are we going online or are we going offline? How much downtime and disruption can we handle if we're going to take systems up there? So I mean, if you're building a brand new system from scratch, not a problem. But if you're going to take some platform, you're going to take a workload and you're going to move it from one place to the other, there's always going to be that potential for a bit of downtime, okay? Now, where Managed Instance far exceeds the capability of Azure SQL Database is that you can take a native backup and restore it with a restore database command. You can't do that with Azure SQL Database. Okay, so I can basically back up to blob store from my on-prem SQL server and then restore it in. But then also we've got the ability to use backpacks and DAC packs, which I hate personally. But that's just me. I find them unintuitive and difficult to package up, get them ready for deployment, and to do it in a meaningful way from a database migration perspective. From a deployment phase, yes, they're great. But if I want to migrate a database, no, it's going to hurt. Okay, there's other ways I'll do it, especially if I've got very large databases. Okay. Likewise, if you've got very large databases, the data migration assistant is great at auditing them. It really sucks at shifting data. Okay. It's not very resilient. It will script out the schema and it will build that schema. It will then script out the data and it will stream the data in. If you get an interruption in your networking, it buffs on you. And then you've got to go back and start again, which is not great. Okay. 3/4 of the way through a terabyte database, that could hurt. It could be men in white coats show up and drag you off because you've gone mad. But this is where the other options come in. Data migration service. Now this is an Azure-based service. Okay. Essentially looks to synchronize the databases from your system up there. There is a big reliance on having VNets and network connectivity through VPNs for that, unfortunately, though. Okay. Log shipping is not supported yet, but it's not difficult to roll your own because you've got SQL Agent up there. Okay, so there's ways and there are means to do it. Transactional replication, it can be a push subscriber. Okay, much like Azure SQL Database can at the moment, which is why I'm not a huge fan of the backpack and DAC packs, because I can just create just do a snapshot and I can push all that data up with transactional replication. And that's keeping it in sync pretty well, so that I can minimize downtime when it comes to doing a cutover. But the big issue really comes around online-offline migration is the application and everything that surrounds the database itself. Where are they? How do they connect? How do you control? How do you repoint them? Is it a massive web farm? Things like that. Is it a whole pile of people with fat clients on their laptops and stuff like that that connects directly to the database? Okay, these are all things that you need to consider when we start moving to basically hosted solutions. It's all about connectivity. Now, we think about migrating them. As I said earlier, what we'll do is we'll create our Azure subscription. Okay, I've got 2 sites here, 1 and 2, various different SQL Server solutions and application servers in them. So I've created Azure, I create a VNet, I've got a resource group all set up. I create my managed instance essentially, okay. I create some Azure blob storage accounts, create some containers. Now because I'm feeling a bit flush with cash, I've gone out and bought myself an express route. Got my other site and I've not got so much money now, so I'm doing a SitetoSite VPN. So here we've got 2 different options. Now, big difference between express route and site-to-site VPNs. okay? By default, things like blob storage, this one here, are not available over the VPN. You're going to the public endpoint, even if you create the VNet, okay? Now, what you can do is create a service endpoint, which you map to the VNet, and put your, basically you're linking your blob store via the service endpoint to the VNet. At that point, yes, we can traverse the VPN to go here, okay? But it needs to be on the same network, otherwise we're going over the public point. So for every virtual network you set up where you've got blob store that you want to access, you're essentially needing to create VPN or pair the networks together. So you've got that consistent link. ExpressRoute, everything that travels over ExpressRoute to Azure is on a private link, okay? So, what we're going to do is I'm going to move some databases. Because I'm an old school DBA, I like backing things up and restoring them. I'll back up those 4 databases and then I just simply restore them. And I'm going to move my app servers. Because I'm on a VPN link, it may be a higher latency, okay? And my application may be very sensitive to that latency. So I want the application servers close to the databases. Azure Virtual Machines. There's services where you can push a button, lift it, shift it. I can deploy the applications to it, all that sort of stuff, okay? Now I can make those servers go away. Now, if they were running something like an availability group, we're talking Enterprise Edition typically, which is tens of thousands of pounds. If I bought them on SA, I can tick the box and I can offset my costs up in Managed Instance, but also when renewals come round, I'm not sat there with 16, 34, 32, whatever cores of Enterprise I need to pay for again. Cost comes down. Don't have to renew the hardware, don't have to renew the OS, all that sort of stuff. I'll move some more databases, backup, restore, move the VM. Now I've got a much smaller footprint here on my site. That means I'm paying less energy, I'm paying less electricity for the servers, I'm paying less cooling. So there's a number of other intangible cost savings as well that you're going to see by taking this stuff and sticking it there. But that's offset by, you're paying monthly subscriptions up here. If you're going to do this type of thing, it's very, very important to optimize the performance of your code, both in the application and the data tier, okay? Basically, if you can tune that query down and use less resources, you can actually scale platforms down, okay? You can get more in there and more bang for your buck, okay? Performance tuning is going to be key when you start looking at using cloud systems, rather than your traditional sort of rack space colos and things like that, where you've got a whole server. I mean, how many people here at the moment consistently run their on-premises hardware at about 80% CPU utilization and sort of equivalent for memory? Normally we sort of freak out when we see it that, don't we? But that's when we've had to buy that and scope it in for 5 years, we buy with plenty of headroom, okay? You need to switch that thinking around when it comes to dealing with platform as a service, infrastructure as a service. You want to be running that kit hot, okay? You want as little headroom as you can get away with, because all of that extra headroom is going to cost you money, okay? Running at 80% CPU is great if you know that you're going to burst another 10% up to 90. But then you've also got the ability, actually, it's coming up to holiday season, we're a retailer, it's going to be Easter, actually, I can afford a couple of minutes downtime to turn that that VM, or that managed instance, or that Azure SQL database, I can actually increase the scale of it, and we'll just run it bigger version for the next month, and then we'll turn it down again. That's where the big benefit is. Just be aware of the workloads you're moving and how efficient they are. If the workload is not efficient, you're potentially going to cost yourself more money. Yes?
What options have you got for changing the amount of resources bought? Is it sort of when you sort of look at it and say, I'm going to change it now, you can't say, I've got a big load at midnight every night?
Yeah, because everything in Azure is scriptable.
You can change it hour by hour.
Yeah, so we've got part of our software monitors Azure SQL Data Warehouse. Azure SQL Data Warehouse is inordinately expensive. You don't leave it sat there twiddling its thumbs. We use Azure Automation with the runbooks to actually turn it off. Or basically make a check. Are you off? Are you off? Are you off? Are you off? And we do that every sort of 4 hours or so. Once it's outside of the business day that we have as a business, doesn't matter, bam, it's going down, okay? If you're doing stuff, you just got to go to Azure Automation and say pause. Otherwise, you'll be in the middle of something like a demo and then gone. But there is the facility to automate those things. There is also the ability to have built-in feedback loops, essentially to say, actually, I'm running really hot now. Certain services in Azure, not typically the data platform services, but typically the app servers and things like that, the app services, you can say scale, give me extra nodes. So if you're using stateless environments with Azure Container Services, Azure Kubernetes Services, you can just fire it in and say, give me an extra 6 replicas. Okay. Yeah, you're essentially using you're pulling the data from you've got REST APIs, which you can pull metric data from, but also you can interact with as well. So you can either write PowerShell scripts to do it, the Azure CLI, you can go through the REST APIs as well, you can build your own little very basic web page app and things like that to give you that capability. It's very, very extensible, that platform. Unfortunately, when you do some of the stuff with the data platform, because of the way that it does things, especially with things like Azure SQL Databases and DB, essentially it will sever all the connections, do the scaling, and then you've got to reconnect. Which is why Microsoft suggests if you're going to be doing stuff with Managed Instance, Azure SQL Database, DW, any of these relational technologies where you're able to use the .NET libraries, they've actually got methods and functions and everything in there that help you build resilient connectivity. So essentially, if there is an interruption, there's native capabilities in there that you can leverage to say, actually, let's do some retry logic. So back off, give it a minute, try again, back off, try again, back, and you build that sort of capability in there. Just simply because it's somebody else's hardware in somebody else's data center over a network link that's not mine. You know, that's the perfect storm for if Joe Bloggs with his JCB digs up the road and your application's around, boom. Someone forgets to renew a certificate on your service provider, it'll go down. Things like that. A good example as well, and this is something when it comes to these sorts of systems, I'm going off on a little bit of a tangent here. If you are planning on taking workloads to the cloud, be they relational, be they anything, architect them for multiple regions. Okay? Early last year, maybe late the year before, I forget, Amazon had a big S3 outage on the east coast of the US. It became very apparent very quickly who'd built their entire service to leverage his resources in that one region. Even Amazon's status page didn't work because all the images that said, no, it's broken, were hosted in an S3 service in the failed data center. The cloud fails, quite simply. It's still running on hardware, it's still mechanical kit, it will fail. There's people in the loop, a lot less now than there would be, but there's still people there, there's still processes, things break. Architect it. If a whole cloud goes down, that's an exceptional scenario. But typically, if you build for multiple regions, you're going to be protecting yourself against a lot of that. A lot of these data services here, Managed Instance, Azure SQL Database, things like that, you can set up geo-redundancy, or you will be able to set up geo-redundancy via a few clicks of the mouse in the portal or a couple of scripts, which will give you, if Dublin goes down, go to Amsterdam. If you're in the UK, if Cardiff goes down, go to one of the other ones, that sort of thing, okay? Be very important when think about that one. Now, I've got those databases I've moved from my other site. I'll get rid of that server, but because I've got express route and because I've got very low latency, I can leave my app servers there. One of the important things to understand in that sort of scenario, if you're going to build hybrid solutions, or even if you're building multi-region solutions, if you're not using the native data transfer between regions in Azure, you get charged for data egress. If you're building hybrid solutions with on-premises components and cloud components, you will be charged for data egress. Ingress is free. Why put a barrier between you putting data into their services? But you want it back, that's where you're going to get charged some money. It's not ridiculous money, but it is still a cost overhead. If you've got very chatty applications, just be aware of that. So the question is, if I've got my web app and my database talking to each other in Azure, do I get charged? If they're in the same region, okay, no. If I had one in Amsterdam, if I had my app service in Amsterdam and my database in Dublin, yes, I'm going to be charged for the data that leaves Dublin to go to Amsterdam, and the data that leaves Amsterdam to go to Dublin. The costs in reality are relatively small unless you're dealing with vast quantities of data. Don't do what someone did, which was put multiple terabytes of data into Hadoop in Europe and have your Power BI tenant in America and then get a six-figure sum at the end of the month, which Microsoft went, yeah, you didn't want to do that. We'll write this off and we'll move your tenant for you. So yeah, Microsoft can be nice, but yeah, it's all cool. Database migration service, I touched on this briefly earlier. It's a fully managed service. You've got to provision it in Azure. Under the hood, there's a couple of VMs and things like that, so it is a service you get charged for. Does rely on VPN connectivity directly to the VNets, okay? So again, you've got to think about how you're going to do the migration, what's going to have access. Can everything talk to each other, essentially? You're not dealing with a gateway service that everything runs through. You need that full connectivity for access to the VNets for it to do the bits it needs to do. Now, once we've got our databases somewhere, that's only half the story. Migration of everything outside of the database then becomes key for us. Now, if we're dealing with Active Directory connectivity on premises, and we've got everything set up, and my applications use Azure Active Directory, I've got them set up, and it all works fine. One of the big things that you need to do is make sure that Active Directory is synchronizing to Azure for a start, through Azure Active Directory, through the AD Connect tool. Very easy to set up. Next, 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 next. Done. As per Microsoft Wizards. What happens, though, when it moves, or rather copies those logins and entities from on-premises Active Directory to Azure Active Directory, the SID, the security identifier, will change. Okay? The SID in the Azure tenant will be different to the one on-premises. Okay? Now, traditionally, one of the issues you've had when you've moved databases between servers, and it's been predominantly for SQL logins, is when you create a SQL login, it creates a SID unique to the server. So if you've ever run mirroring, log shipping, availability groups, things like that with SQL logins, it's not a simple case of creating a login on the other side of the same username and password, because the security identifiers that link the login at the server level to the user in the database will not match, which means the authentication will fail. So what you need to do is either, now there are there's stored procedures out there and code out there which will allow you to script out logins with the password hash and the SID, which means you can take that and then just use a create login statement with the SID, with the password hash, and that will push in there, and then they'll line up. Alternatively, alter user for login, boom, and that will align them again. There is also a PowerShell. Anyone who's dealing with SQL Server in any way, shape, or form, there is a PowerShell module called DBA Tools. Okay, it's an open source one up on GitHub. Use that. It's got a huge number of very useful commandlets in there for doing just that sort of thing. Migrating jobs, migrating logins, migrating linked servers, migrating credentials, all of these server scoped elements, which means you can automate it because it's all done in PowerShell. Doing it with T-SQL is a freaking nightmare. That's not what it's really designed for. T-SQL is really designed for DML and DDL. So data manipulation language, data definition language, doing stuff in the databases. Administering the server was just well, we've got to do something. We might as well use T-SQL for it because that's what the guys are scripting it in. The PowerShell side of things uses SMO, makes life a lot easier. But you're responsible for all of this stuff. It doesn't go with the database. Just make sure that's another point in the migration process. The migration, as we said, it leverages back up to URL. Now, this capability came in with SQL Server 2012 CU3, but essentially you can back up directly to an Azure Blob Store container from the SQL Server. Okay, really nice and easy. You just need to create a credential in SQL after you've set up the Blob Store component, and then it just treats it like another backup location. If you've got very large databases, split it out to multiple backup files, you'll see better throughput. it depends on how big your bandwidth is, really. But large databases, I mean, if you're dealing with tens of gigabytes, you just got to think about how easy is it to upload one large database file, okay? Versus, well, let's break that down into 3 or 4 different streams, so we're dealing with smaller files, you get higher utilization on there. Don't do it in the middle of the day when everyone's watching cat videos, because you'll still have no bandwidth. And also you have very unhappy people because they can't watch their cat videos, because you just saturated it with a 100 gig database backup. One of the other things as well, make sure you use compression. Compression capability is natively built into SQL Server. It will compress it before it sends the data, okay? So you'll be sending less up there. Less on the wire makes it a little bit quicker, but multiple files will see better utilization of the network resources you have available. Likewise, if your bottleneck, if your VMs are all in Azure and you're doing that sort of backup service there, you've got large amounts of bandwidth, you're probably going to bottleneck on the Azure storage, so multiple storage accounts. Just scale it out, okay? If you're using, right, backup to URL requires credentials created at the server level. If you're using 2012 or 2014, there's a specific syntax for the creation of the credential. If you're using 2016 or 17, it's a different syntax. Different functionality. And we'll have a quick look at those in a moment when we get to it. Reduce your costs. If you've got SA, don't forget to tick the box, and don't forget to decommission your servers, because it will save you money. Now, one thing I haven't covered here, and we'll talk about briefly, is workload analysis. There are some tools available, okay? I am a huge fan of a tool set called RML Utilities. I don't know if anyone's heard of this. Basically, RML is Replay Markup Language. It is a free tool set from Microsoft, okay? In the same vein as PSS Diag, SQL Diag, Nexus, and that sort of tool set. But essentially, RML Utilities contains 4 applications. You've got read trace. So when you take either an extended events trace or a SQL trace, read trace does exactly that. It reads it. And you've got 2 options here. One, you can have it push all of the metrics and telemetry data it discovers through reading that trace into a database. Or you can also get, or you can get it to create RML files, which are then used by a tool in that suite called OStress, which will read the RML and basically replay the workload. So what it allows you to do is take a backup of the database, restore it, but when you're taking that backup, you're capturing the trace, turn it on RML, and then I can replay that exact workload into the database on the new platform, the new server, okay? If you want to simulate multiple clients, there's also a tool in there called Orca, which essentially is an orchestrator for OStress. And you can either run it in a stress mode or you can run it in a replay mode. Which means I want to maintain the timings as best I can and the intricacies over maybe, say, 8 clients. So 8 instances of OStress will have the workload distributed amongst them, and they'll all interact with the database. And then there's a reporter application, which reads the database that readtrace creates. One of the advantages of this is, if you're going to do the whole capture a workload, turn it into RML and replay it, capture it again there, what you can do is then use a readtrace to read the second one into another database, and the reporter tool can actually do a comparison between the 2. Straight out of the bat. Saves you having to write all your own queries. Makes life a little bit easier. I'm a huge fan of RML. If anyone suggests you use distributed replay that came with 2012, laugh at them, because A, the controller costs you money. You need a full SQL license for the controller. And B, it is inordinately complex and a pain in the backside to set up. Okay? So those are the key things I'd have a look at from that side. Now, let's try and migrate some databases. What I've got here is a very basic little application that we use called SQL Spoof. No, I'll zoom it. Essentially, it's a very, very basic application that runs a bunch of queries for us. Now, I've got 3 databases currently sat on my SQL Server. Okay, let me just clean this up, disconnect. So, what I've got here are 3 little sales databases, essentially. Sales Archive, Sales Data Mart, Sales Sandbox. That SQL Spoof database that you see at the bottom is the one that's got all my queries in it, essentially. Okay. I've got a bunch of logins. My boss who wrote this is a big Avengers fan. So what do we need to do? Well, we need to get all of these databases, well, these 3 databases and the logins up to my managed instance, and then I redirect the application, basically. So that's what I'm going to try and do. Emphasis on the try. So, let's see. Let me just double check I've cleared all the things that I need to clear. Make sure I've got everything removed. Yep, okay, so we should be good to go. Now, let's start. Can everybody read that okay? Okay. So I logged into my Azure account earlier when I was copying and pasting passwords. So essentially what I'm going to do here is I'm just going to set a bunch of parameters. Now, this says MS SQL tips because that's where my blog post is, and that's where you can get all the code that I'm about to run, along with basically a step-through guide. Okay. So resource group, I need to create one of those. Need to create a storage account. Storage account type, standard, locally redundant storage is what that stands for. Okay. You can have geo-redundant, zone-redundant, geo-redundant, read-only as well. Okay. The more redundant and the further apart it is and the more online it is, the more money it's going to cost you. Also, there are 2 different types of storage account at the moment, and we take a slight tangent on the Azure platform, but you've got general purpose storage and general purpose V2. General purpose storage is more expensive for data at rest, but less expensive when you're interacting with it. V2 is less expensive at rest, more expensive when you're interacting with it. Just bear that in mind when you think about what you're going to put on there. If it's whatever you're going to do is very chatty, go with V1. If you're going to put it up there and never talk to it again, V2. Okay. Azure region, I'm going to put it in West Europe, and that's my container name. When I'm going to create the blob storage, I'm going to create a container called database backups, and I need to create a policy as part of this for when I create the shared access, essentially. So I'm going to run this one here, which is create the new resource group. Okay, well, let's move this up a bit. So scroll down. So I now have my resource group. Now, one of the things you'll notice here is that it's got tags as a property. Ordinarily, if I was deploying this type of thing to production, I would be tagging these resources. Essentially, this is a way that I can then identify those resources very easily and quickly. So find everything with my, so for example, you're running a certain application, okay? That application has app services, resource groups, databases, blob storage, all these things. If you tag them all with a common property, then you can easily search for and identify those resources in the subscription. And that can actually filter through to billing as well, if you're looking to rebill things, okay? So I'd strongly recommend a good tagging naming convention if you plan on using Azure. Just makes life a little bit easier about breaking down those barriers and saying, okay, well, who's using it for what? Now, when it comes to deploying resources in Azure, deploy them into resource groups. Only deploy into that resource group something that is within that container, essentially. So I've got a bunch of, if my application contains VMs, Azure SQL Database, and blob storage, if it's something that I'm going to basically tear down and redeploy the whole thing again, that's what the resource group's for, okay? Very, very easy to just wipe everything out and redeploy from scratch. If you need it to persist, maybe you need to break them out into multiple resource groups, okay? Just think about how you're going to logically lay things out, because you might want to burn an entire resource group down and then redeploy the whole thing. So you need to think about whether it's stateful or stateless when it comes to what you're doing with it in the context of that. So many of your databases, you'll probably want to be stateful. tearing it down and then deploying it and repopulating all the data is not something we typically do, unless it's dev. So I've created my resource group. Now I'm going to create a storage account, and I'm going to create some account keys and set the storage context. So this is, we'll go through the portal in a minute, because I know highlighting code and executing code is really not very exciting and not very intuitive. But this is a lot quicker than me trying to do it through the portal. Essentially, we'll create the storage account. The storage account keys, now because I'm using 2017 in my VM, what I need to do, whilst that's doing that actually, we'll come across to the portal. Let me just close these down. Storage accounts. There it is. So, I'm into my storage account. Let me just fire up Zoom it again. So, if you're using SQL Server 2012 and 2014, you need to come through to the access keys, okay? When you create the credential, I'll show you the credential T-SQL statement in a minute, but essentially you will need the storage account name and one of these two keys, okay? You'll need that information to be able to put it into the create credential statement. If you're using 2016 or above, managed instance, 2016, 2017, you need to set up a shared access signature. Essentially, this is a one-time code. But what you can do here is define the types of access, the level of permissions. It's a lot more granular than using it with a standard name and keys, okay? You can say validity time. When's it valid from? When's it valid to? Restrict it to inbound, outbound IP addresses, things like that. So it's a fully capable, very granular security control mechanism for granting or restricting access to your Azure Blob Storage, okay? You can say only through HTTPS or HTTP as well, and then you generate the SAS key. So I'll generate one here independently as well, because it's this SAS token here that we want. Whoops. Okay. When we take the property from that box and take it to SQL Server to use the create credential statement, this question mark needs to disappear. So if you use the native copy bit at the end, it will copy it with a question mark, and then your statements, you'll create the credential fine, but all of your backup statements will fail because it's incorrect. You make the question mark go away and everything's good, okay? So those are the two different access mechanisms depending on the version of SQL Server. If you're using prior to 2012, you're going to have to roll your own with PowerShell, okay? Essentially, you'll be backing up locally and then copying the data via PowerShell, AZ copy or whatever, to blob storage, okay? There's code in my blog post as well for that. So, fingers crossed this has now done what it's supposed to do. Yes. Okay, so now I need to create my container, which is done. Now, you know the shared access policy and everything we just created through the portal? This is it doing it with PowerShell. Set that up. So, now I can create my T-SQL statements. So I'll just set them into some there, and then write that out to the console. Actually, we'll do it one at a time. So for 2016 is this one here. Create credential. Now the name of the credential for 2016 and above is the full path to the container. Okay? With identity, you're telling it it's a shared access signature, and then you're providing the secret. As you can see there, there's no question mark on it. Everyone able to read that all right at the bottom? If I'm doing it with 2012 or 2014, my statement's slightly different. The credential name can be whatever you want. With identity, the identity is now the name of the storage account. And the secret, again, is that key that we took from that page. Okay? Now, you can rotate these keys at any point in time to invalidate these credentials. So if someone does lose them, wipe them out. Okay? So, now I need to create my credentials on the servers. Now, you'll see my very, very secure password here, just simply because the password has to be very long for managed instances. I think it's a minimum of 16 characters. And I was very, very tired that day. So I can use invoke SQL command. Now there are, you remember I mentioned DBA tools? There is a create DBA credential commandlet. However, if you've not got the latest Management Studio installed, it won't work. I'm still working with Chrissy and the team on that one to try and figure out quite which DLL it is we need to get hold of and pull in, because Microsoft keep changing things. So I'm going to use invoke SQL command, and I'm just going to execute the T-SQL statement I generated. Okay, so this is going to be on my on-premises or retail SQL server, WinSQL 0. Okay, and then I've selected out and said, okay, well, there's my... So I'll set these up. And then I'm going to create that on my managed instance. Same way, this time, just invoke SQL command. There we go. So I've created the same credentials, which because I'm accessing the same blob store. You can create different credentials depending on how granular and how much you want to segment your security. Now, for brevity, he says with a ... basically going to set the URL path. So there's my backup path that I'm going to pass into my backup statements. And this is an example of the PowerShell commandlet from DBA tools, backup DBA databases. So I'm just going to say do these. Now, one thing I'll say is when we come to do the database restores, we can't use the commandlets from DBA tools because Microsoft have changed the way that the restore command works on managed instance. Okay, so the standard SMO stuff that the team have written doesn't work. So let's just back the other two up as well. Whilst I'm waiting for that, let's nip over to the portal briefly, and then we'll come down to containers, and then there's my container, and there are my backups. Backed up straight to URL. Okay. Now, we'll do that in a moment. I need to come to my managed instance, and then sales archive from URL equals, and do that. So what I'm going to do is I'm going to create 3 of these because that will make life really unpleasant for it. Come back to the container and let's just get the blob properties because that will give me its full URI, which means I can come to my restore database. So sales archive. Oops. Okay. So we'll kick that off. Yep, that's on the way. Now, you can't use things like with stats for managed instance. The reason being is what Microsoft did with managed instance, they recognized that there's going to be a potential disconnect and disruption between my client and the database server. If I'm doing a very large restore, that can potentially take a lot of time. So what that means is they basically almost treat it like a sort of RPC, in that as soon as I hit go, it actually sends the command. So if I lose that connection to the server, the backup will not fail, it will complete. Because it knows that it's in Azure, the blob's in Azure, well, the internet means that the internet could have gone away, so I'll just crack on and get it done. So sales data mart, we'll restore that. Now the restores may take a little bit longer on Azure, managed instance. The reason being is that under the hood it's actually generating multiple replicas and streaming all of that data down into them as well. So it's instantiating multiple versions of the database at the same time. So this should be my sales sandbox. Another thing you'll notice that I'm not doing here, can everyone read that all right? I'm not specifying anything like with move, which ordinarily if I'm moving from one server to another with different storage layouts, I'd need to do. Managed Instance just handles all of that for me. I just say, just restore this and stick the data in the appropriate places on your storage platform. Okay. So, whilst that's doing what it's doing, let's crack on and move some databases stuff. Let's move some users around. Now, you saw I had a number of logins that I need to migrate as well. This is where PowerShell comes to the fore. So, I'm going to create my credential. I remember my password. No, it's that one. No, not question marks this time. Okay, and I'm going to basically set an array of logins I want to move. Now with the copy DBA login, again, this is from DBA Tools, you can basically say these logins, this login, all logins, or exclude these logins. It's highly versatile. So I'll just run a for each loop and off we go. And I'm going to hope that it works. Well, there's no red yet, so that's always a bonus. Yay, successful. So I've actually just moved those logins across, which is nice. Oh, wrong one. So now if I come back to here and then expand that out on my... There we go, got them all. Now if I... Yeah, it looks like they're working now, which is good. So if we select from server principals here, come down, we'll find Stark. Okay. Come down to here. Find Stark. Do that. And this is where I figure out I did something wrong. There we go. You'll notice that the SIDs line up. They're the same SID. Okay, which is this one here in the middle. Yes. The joys of the human eye and pattern recognition. Okay, so the SIDs are the same. That's the joys of migrating. If I just created, it with a standard new one, it will just create a new SID, and then my databases won't line up, and nothing will work. Although at the moment my databases aren't restored, so I've run out of time. This is one of the joys of preview services. Got most of the way there in about 10-15 minutes, so that's not too bad. But essentially all I'd need to do then is cut back across to my app server, stop, come in here, update my config file, because I've migrated all my logins, and then press start again. Done. Okay, so it can be very, very quick and easy. So sorry I couldn't complete that one for you. I was being a little bit ambitious. So we'll go through a quick summary. Really, what we're looking at here is, yeah, we now have another platform as a service offering available to us. If you're migrating from on-premises, it can give you a lot of value. If you're starting with cloud-born solutions, maybe not. Depends on how many databases you need, the architecture you've got, the type of design patterns you're going for. Very high feature coverage, which makes life a lot easier for those that are migrating. And the migration paths that are open to us are ones that are tried, tested, and trusted. Backup and restore, we've been doing that forever. Transactional replication is still a very, very viable option for migrating databases when you want to get them as close as possible for minimizing downtime. Log shipping, backup restore, it's all available to us. Has anybody got any questions? Hopefully I've made you think, oh, this looks not too bad. Let's go and have a play with it. One thing I will say is you need to sign up to the preview conditions, and that can take, because someone's got to go and tick a box and say, yes, this is right. Because there's big capacity issues as well, because there is a huge demand for this service, it can take a little while to get approved for the preview, and then it takes about 12 hours for an MI to deploy, because essentially you get put into a queue and it processes through, and there's that demand for them and limited hardware capabilities at this point whilst we're in preview. Obviously all of that will disappear when we hit prod. Well, if no one's got any questions, thank you very much.